And it looks like we're live. Hi, everybody. I'm Kevin Ragsdale, and I'm going to be presenting easy multi-threading with Visual FoxPro. Once I remember where my slides are. There we go. A little bit about me. I've been working with FoxPro since about 1993. I'm the Desktop Alerts VFPX project manager. And when I did the desktop alerts about 15 years ago, it opened the door for me to speak at conferences and user groups and things like that. And for those of you who don't know me or haven't heard the stories, I have a history of killing conferences. I've spoken at Advisor DevCon, and after speaking there, Advisor decided not to do any more DevCons. And also the Fox Forward conference, after I spoke there, they decided they weren't going to do any more. I've been pretty lucky with Southwest Fox. I've spoken at Southwest Fox several times, and we kept plugging along every year. In 2019, I was invited to do the keynote at Southwest Fox, which was just a thrill for me. And unfortunately, after I did the keynote in 2019, we had a global pandemic. Apparently, it was triggered by my keynote address at Southwest Fox, and we haven't been able to get back together in Phoenix ever since. Hopefully next year we will. And in the meantime, I just tell everybody that I'm really sorry about that. So for the last several years, I've been working with Bo Durbin and his team at Zoom Geeks. And at Zoom Geeks, I've primarily done a lot of work integrating FoxPro with other APIs and other software packages, and also have been doing a lot of web development. And one last thing about me that you may not know, I have not been able to independently verify this, but for about the last 35 years, my father has told me that I was the inspiration for Winston Groom's fictional character, Forrest Gump. So for those of you who like to put evaluations for me that say things like stupid is, stupid does, then you'll know that that really doesn't bother me that bad. So I'm going to go ahead and turn my camera off. And hopefully we'll just be back to the slide at that point. Before we talk about the agenda for today's session, I was lurking in one of the social rooms earlier today, and somebody had mentioned my session that was coming up and said that Kevin did a session about multi-threading a few years ago at Southwest Fox, which is true. It was actually 2011. So it was 10 years ago when I first talked about multi-threading at Southwest Fox. They were wondering, well, they said something like, I wonder what's changed since then. And the biggest change in the session between 10 years ago and today is that I'm older than I was then, and I'm about 40 pounds heavier than I was then. As far as the actual agenda goes, we're going to look at what is multi-threading. We'll talk about advantages of multi-threading, and I'm going to introduce Dmalt.DLL to you. It was written by Christof, who just did the first session of Virtual Fox Fest. This is a DLL that he actually wrote. We'll talk about creating event handlers or callbacks for our multi-threaded DLLs, and a neat little easy way to manage our threads and our callbacks. And finally, we'll wrap up talking about the disadvantages of multi-threading, which, believe it or not, there is, a couple of disadvantages to it. For me, the need for multi-threading kicked in, I guess it was around 2007, 2008. I was working on an application that really interrupted people's workflow as they tried to do things. Everything in this application, all of the data that it got, it pulled data from different online sources. So you would click a button or a link and it would go out and get that data. But you couldn't do anything in the app while it was retrieving that data and processing it. Then you would go to the next one and then the next one. And it seemed to me like I remembered seeing something about multi-threading in Advisor magazine. And that was actually from September of 2006. Someone had sent in a question and they said, many things would be easier if I could run them in a background thread. Is there a way to create multi-threaded applications in Visual FoxPro? And Christof was, I believe, like the contributing editor at the time that would answer the questions to the magazine. And Christof wrote back and said, there's a clear answer to that question. It depends. And what he meant by that was, yes, we can create multi-threaded DLLs in Visual FoxPro, but Visual FoxPro and multi-threading is a little bit different. If you want to execute your Visual FoxPro code in a different thread, then you have to build a multi-threaded DLL, of course. And we have been able to create multi-threaded DLLs in Visual FoxPro since, I believe, Visual FoxPro 6 Service Pack 3, I think was when they first added that. The only problem with that is that if you're using that DLL from within FoxPro, Visual FoxPro loads the DLL in the same thread as the main application. So if you're loading that DLL from Visual FoxPro IDE, it's loading it in the same thread that the VFP IDE is working in. If you've got your own application that you've compiled into an EXE and the user is running the EXE, and then it wants to load the DLL, it loads the multi-threaded DLL in the same thread as the EXE that's calling it. So it can get a little complicated. Building multi-threaded DLLs in Visual FoxPro and then using them in other environments like, say, ASP.NET, or I think possibly even Cold Fusion handles it differently. They will actually load the DLL in a separate thread for you and takes care of all that work. Visual FoxPro does not. I guess at this point, we should probably talk about what is multi-threading. For me, multi-threading is just the ability for my app to do many things at the same time, especially with all the multi-core processors that we have, which we just seem to, it just keeps growing over time. So I think when I first did this session, I believe I had a quad-core PC, and now it's like an 8-core PC, which is actually, I guess, kind of low end for right now. It frees up your user interface, because if you've got something that may take a little while to run, if you push it off into a different thread, then your user interface is available right away. That allows the user to follow their workflow instead of having to follow your application's workflow. And what I mean by that is it improves the user experience, or the UX, I guess, because the user will feel as if they're in control of the application instead of the other way around, and feeling like the application is in control of them. And that's, you've probably worked with applications like that. I know I have. The one thing that people don't like is for an application to make them feel dumb. Another thing they don't like is for an application to just control every single thing that they do. You know, you must do A before you do B, before you do C. And, you know, we don't all think the same way. So not everybody's an engineer. So if your application looks and feels engineered to a regular user, they may not care much for the application. There are several advantages of multi-threading. For me, the number one advantage of multi-threading is the responsiveness of your UI. As soon as you kick off something in a different thread, your UI is available for the user to use. And one thing that I mean by that is your application will not report back that, or Windows will not report back that your application is not responding. And this graphic I just put up, it's an older graphic. I think it's from Windows 7. I think Vista and 7 had added the little bits on there on the dialogue about closing the program or waiting for it to respond. But it used to drive me crazy. I guess really when Vista came along, it seemed like it happened more often than not, where your application would start doing something and it would take a few seconds for it to take care of it. So Windows would conveniently throw the words not responding in the title bar of your app. And they would also report to Task Manager that your app is not responding. And unfortunately, when that happens, users, if they're looking in Task Manager, they're most likely just to right click on your app and say end task. Otherwise, if they're not in Task Manager, but they're in your app and it feels like it's not responding and they see that it's not responding in the title bar, they'll start clicking like crazy. And they'll click all over the app, and eventually Windows will dim the app. It'll kind of dim into like a weird white color. Sometimes it'll pop up a message like the one here on the slide. I think Windows 10 and Windows 11 do a little better job. They don't seem to really push this dialogue on you the way Windows 7 did. Windows 8 actually added another button to this dialogue that said try to restart the program. So it was confusing for users, to say the least, if your application gets busy while they're using it. And that kind of leads me to what I call the 5-second rule. And, it's kind of like, where does Windows get the idea that my application is no longer responding? And it's actually a pretty easy answer. Windows provides this event queue. And if your application doesn't poll the event queue for a while, and I put in parentheses in 5 seconds, then Windows will assume the application is hung and it alerts the user. It alerts the user by putting not responding in the title bar, telling Task Manager that the app is not responding, and possibly popping up one of those dialogues like I showed in the slide. I stole this off the internet. I think I've got a link to it in the white paper, but one of the answers for it was like, if your application is doing like expensive calculations, and basically if it's doing something that's going to take more than 5 seconds to do, then you really ought to split that out into a worker thread or split up the processing just to make sure that your application continues to poll the queue regularly. If you're able to do that, then Windows will not report back and say, hey, this app is not responding. Would you like to kill it? So there's several things that, for me, that would take like more than 5 seconds. One thing is I've got a few apps that integrate with Salesforce. And so you basically make a web query to Salesforce to get Salesforce objects back. And that's great when you do one of those API calls and it only takes a second or two. But it's not so great if it takes 40 seconds for them to package up the data, run the query, package the data, and return it back to you. And not only that, once you get the data back, then you've got to do something to put it into a context that you can work with in Visual FoxPro. So if it takes 40 seconds and Windows pops up not responding, your user will start clicking all over the window. They might try to kill the app, even with like a Control-Alt-Delete and Task Manager. And I've even experienced this in putting together demos for this session. When I start clicking around the window, I may accidentally click the exact same button that I clicked to start the process that is taking 40 seconds to run. And what happens is, once your application gets out of that hung state, so to speak, and it has been collecting all of these things for the Windows event queue. Hey, he clicked here. Hey, they clicked there. Hey, they clicked this. They clicked that. So all of those have stacked up in the event queue for Windows. So then once Windows is able to start processing the event queue again, it starts processing the messages for all those clicks. And you can inadvertently start that 40-second process all over again once it picks up that click. So you have to be really careful with what the users are doing on that. Something else that could take a little while is just checking for an application update. A lot of programs will, when you first start a program, it might call home and say, hey, have you got any updates? Here's the version I'm running. Have you got a newer version for me? 99 out of 100 times when you run that, it'll be blazingly fast. It'll take a fraction of a second to call your server and have the server respond back with a, yeah, we've had an update, or no, we don't. But then again, you might have one of those times where it takes 6 or 7 or 8 seconds. And when that happens, your application's not responding. And that's before you've even really gotten the application going. You know, you may just have a splash screen up while it's doing a check for updates in the background. You can check for updates in the background on a separate thread. And then once you have an answer, even if it took 30 minutes for the answer to come back, then you could just alert the user and say, hey, by the way, we've got a program update for you. So there's also, as part of the 5-second rule, there's also a deal where you may have many things that you want to do at once. And we'll take a look at that in one of our demos. For now, I guess we ought to jump into a demo. And I've got to say that for a session like this, coming up with ideas for demos is extremely difficult, especially trying to visually show something that's going on. So you're going to see some demos and you're going to say, well, what was that? That was pretty useless. And the first demo that we're going to look at is sample DLL. And this DLL only does one thing. It has an OLE public session class, which called Easy Empty Server. And the only thing that it does is got a method called some lengthy process. And what it's going to do for 20 seconds, it's going to print to the Visual FoxPro screen, hello, virtual FoxFest, and then the current time. When it gets done doing that after 20 seconds, it's just going to sit and pause for about 10 seconds, and then it'll say done to the Visual FoxPro window. And that's all that this DLL does. So that basically this project, the sample project, has the one PRG. And let's see, we're just going to build it on the fly here. Call it sample DLL and replace it. And you'll notice at the end, it did the build and then it registered the COM server in the registry for me on my dev machine. The only reason it did that is because I'm running Visual FoxPro as an administrator. If you try to build the DLL and you're not running as an administrator in FoxPro, it will only build the DLL. It will not be able to register it on your system. And in order to use the multi-threaded capabilities, the DLL has to be registered on the system that it's running on. So starting VFP as an administrator for me is kind of a no-brainer because I'll end up building something, 10, 15 times a day. And I just want it to go ahead and register for me. So I've got this function here in a different program. It's called non-threaded. And the only thing we're going to do is instantiate an instance of this COM server, which is a DLL, this sample.easyEmpty server. Then I'm going to call some lengthy process and pass in the underscore VFP. And so we'll just go ahead and run this. So it's a multi-threaded DLL, but I'm just instantiating the DLL from within FoxPro. There it goes. Every second, it seems to be writing something to the screen. And you can see my cursor is a circle. And I'm clicking around and nothing's happening. Now I even click the document window, data session, properties. Nothing's going on because I just can't do anything here. I think now it's in that 10-second hold. And still nothing is happening. And now all of a sudden I've got control back because it says it's done. That was that 10-second holding period. And if I hadn't hidden one of these columns earlier, it would have said not responding. But you can see where I had been clicking all through the process. Once the application got control back, Windows went ahead and processed all those clicks that I did. So we've highlighted LODLL here, and it actually clicked all of these tabs and landed on the last one I clicked on, that was properties. So it's a pretty weak example of a long-running process, but it does show what happens in your user interface when a long-running process is going on. And there really wasn't much to show there. So I'm just going to go ahead and start up our second demo. The second demo is the exact same thing as the first demo. It's the sample project that we had with the one file, which is just this one comm server that takes 20 seconds and then holds for 10 seconds before it's done. So all of that's exactly the same. The difference this time is how we're going to run it. This time I have a function called multi-threaded. And in this function, we're actually declaring a method inside of the Dmalt.DLL. And then further down, it's hard for me to do this because I can't really see my cursor with the, I can't see my mouse pointer in this virtual machine. We're going to call a method called create thread with object inside of Dmalt. And in there, we're going to pass in the comm server that we want to load into a separate thread. And we'll send in the method that we want to run inside of that comm server. And then we send in a callback object, which is the underscore VFP. And we'll go ahead and run multi-threaded. And hopefully this will come across. It's kind of difficult online to see what it's doing. But as you can see here, I got control right back to the application. Of course, I mistyped that, but there we go, test, and it went to there. I can click over here and things are actually working. I could actually modify sample main, and I can modify this file if I want to while the program was running, while it was off doing that thing. And there you can see it just finished after doing that 10-second hold. So for me, that's the real power, and really one of the few ways I can show to demonstrate the power of multi-threading is that if you have this long-running process, but the next step in your application doesn't necessarily depend on that long-running process, you can give control back to your user immediately. They never feel as if they're being held hostage by the application. So, which is a pretty powerful thing to me. That was the second DLL. So this is a good time to introduce Dmalt.DLL to you. This is a C++ DLL that was written by Christof. And what this DLL does, it's a helper utility in that it actually will load your COM object into, or your COM server DLL into a new thread for you, because Visual FoxPro doesn't do that for you. So you have to have a helper. At the time I first did this session about 10 years ago, there were probably 4 or 5 different helper utilities, so to speak, for doing multi-threading in Visual FoxPro. But this one was by far the easiest one that I used, and I kind of had like an aha moment right away when I first started using this one. This DLL has 2 different methods in it. One is create thread with object, and the other is create thread with string. So you could actually send in an object or a string, into a separate thread. It creates the thread, it initializes the apartment, it loads the COM server in that thread, it takes care of all that work for you. In this session, we're going to exclusively be using COM objects. So we'll be using the function create object with, or create thread with object, instead of create thread with string. Is there any questions yet, Rick?
There are questions, but most of them answered by other people. But there is one extra one here. Will the additional thread run on a different CPU?
It'll run on a different thread or a different core for you as far as the processors go. Yep. But that's up to Windows and the Windows scheduling, how, for how that ends up working out.
That's all.
Okay. That's cool that other people are answering. I was hoping Christof would be in the session and he would be answering all the questions for me before we get to the Q&A. So using the Dmalt DLL is pretty simple. You declare the function just like you do with any other DLL, like with the Windows APIs that you may do in code. It takes 3 parameters. Like I said earlier, the COM server that you want to load, the method that you want to run, and the callback object, which will do further processing on the result of the multi-threaded object. And on the parameters, there's a couple of things. The server name and the method name have to be sent in as Unicode, which is pretty easy to do. It's just a null terminated string. So we do the COM server name plus char0 for the null terminated, and we do a string conversion on it with the parameter 5, which I believe is the double byte characters to Unicode. We'll do the same thing with the method name. Basically, you just add a char0 and you do the string convert 5. The callback object has to be a COM reference. So you can't really just send in a Visual FoxPro object. So if, say, you've got a callback that's a PRG-based custom class, and you want to pass that in, it has to be a COM reference. So what you could do is you create the object like LO callback is equal to create object, blah, 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 whatever your custom class is. But then to convert that VFP reference or callback into a COM reference, we'll just apply _VFP.eval for that object that you just created. And that takes care of it for you, which was a nifty little trick that I learned, however many years ago when I first read Christof's article. Let's see. Now we're going to take a look at making multiple API requests. And this one got a little bit tricky for me, so I may have to run this a little bit differently. I'm going to run it in a separate session of VFP. And there we go. All right, so this is just a normal everyday form. And basically what I'm going to do, and if you've seen this session before, you've seen something similar to this. On my website, I've got a table that has some addresses for some FoxPro blogs. So when I click on Get Blogs, I'm just going to make a request to my web server and say, hey, have you got a list of FoxPro related blogs? And it's just going to return the list back. And 10 years ago, I used VFP Connection FLL to do everything in this session. I have had all kinds of trouble. I can't really use VFP Connection at this point due to the differences in the SSL and TLS and all that's going on. I don't know if anybody else is having that issue or if it's just something that I couldn't crack. For myself, almost exclusively, I use the Westwind internet controls, the WWHTTP and all. But for this session, I'm using just a plain MSXML2.XML HTTP. So we're just, it's a different way of connecting, but it's doing the same thing. The main reason why I'm doing it in a different session is because that tends to cache the results. So the next time you run it, it runs blazingly fast because it didn't actually make any requests for you. So this is the result. And it was actually kind of cool because on my server, I used the NF-JSON program from VFPX. And I'm actually, when it creates, it gets the query or the cursor, and it turns it into JSON, but it does it for VFP. So it actually returns the structure along with the data. And then on my client side here, when it gets the data back, it just does the NF-JSON and creates the cursor on the fly. And I really like that. It's been pretty cool. But now you can see I've got 31 blogs that came back. Now I want to get the author or the title of each of these blogs. And that means I've got 31 things I need to do. And if I've got 31 things I need to do, that means I'm going to do them, basically one at a time. And so when I click Get Authors from Blogs, it's going to go out for each one of these rows and say, hey, give me whoever the author is or the title of the blog. And it's running and it's going. I mean, it's pretty quick. Everybody has, pretty fast internet connections these days. It really depends on the website as well, though, because the website could be kind of slow as far as getting a response back from it. And finally, it's done. So it took 25.5 seconds to get the authors or titles of 31 different web pages. And I forgot to actually start clicking around on the screen to see if it would say not responding, but it would have. If I had started just clicking around on the screen, it wouldn't have done anything, although it probably would have showed a not responding up here on the title bar. I just forgot to do that for the demo. And I'll tell you what, instead of looking at the code, why don't we just go ahead and run the other demo? Then we'll come back and look at the code. The user account control that's popping up every time I start FoxPro is because I've told it to run as an administrator. And so I get the user account control every time I start it up. This is the exact same form, except this time we're going to use a multi-threaded approach to get our data back. And just for fun, I'm not sure which VFP we're looking at here. I'm going to click Get Blogs, and that did go really fast because the XML HTTP has cached those results. So I'm going to go ahead and click Get Authors, and it's running basically 31 requests all at the same time. And I'll show you how we did that in a minute, but you can see it only took 2.8 seconds. And I also forgot to click the cancel button and click around, mainly because it was so fast doing that. If I was checking 100 sites, I would have a little more time to start clicking around and see what we would get. But that's pretty quick. And basically, we just sent off 31 web requests all at once. So I'm going to bounce back to my copy of Visual FoxPro on here. All right, this is the original Get Blog screen that I showed earlier. And let's just see what happens. When I click on the Get Blogs button, whoops, I keep losing my mouse here. When I click on the Get Blogs, it does the same thing that we did in that original demo where I'm just instantiating the COM server and calling the Get Blogs function and sending in this form as the callback. And this form has a method called onResolve. And onResolve gets called by that COM server. When it has a result back, it passes the result back to this callback function onResolve. And that's where it did the JSON read and then the JSON to cursor and just went through and updated the blogs entries. Not much to see there. That was on, oh, here we go. Sorry, I just confused myself for a second. Here we go. Okay, this is the actual COM server called Blog Retriever, or the class is Blog Retriever. And basically when it initializes, it just tries to get XML HTTP object to make the web request. And you can see I've got a destroy method in here just to get rid of that reference on the way out. And our function called get blogs, and we're passing in the callback of this form. This function just basically makes a call to my website and says, hey, give me a list of blogs. And it makes the XML request and all that stuff. When it gets a result back, if an error happened, it's going to call a function called onReject back on the callback object. If it was otherwise, if it's a success, then it's going to send the result, which is basically just a web or the JSON string, to a function called onResolve, or a method called onResolve on the callback object, which was onResolve on the form. So the form actually took care of being the callback. And I should probably reopen that form. When we did the get authors, this basically does the same thing that the DLL did. It was just, I'll create the XML HTTP object, and then it scans through the cursor behind the grid, scans through the cursor and says, go out and get this URL. And then once you get it, let's replace the author with whatever the result is that we got back. So, oh, there we go. Yeah. It's pretty simple stuff. It just updates the cursor and then refreshes the grid and all that good stuff. This one was the one where it, since we scanned through the table, it did one at a time. So it started at the top and it said, hey, go out and get the author for this one. And then it went to the next one. Go out and get the author for the next one. Now, if we take a look at the other demo that we did, the one that was multi-threaded all the way around, get blogs, we actually declared the create thread with object in Dmalt DLL. Sorry, I'm trying to find my cursor here. There's another Windows API that we use called close handle, and that was documented by Christof in his documentation for Dmalt. And then down here is where we actually make the call. I say create thread with object. I send in the com server, which is blog stuff. It's the DLL named blog stuff. The class is blog retriever. We tell it to get blogs, and the callback is this form, which is right here. I did LO callback equals this form, and then to make that a com reference, I did the VFP eval LO callback. And that was just to get the blogs. So let's see what happens when we click get authors. This time I scan the table again, just like we did before, except this time for each one of those records, I'm going to create a callback object and then launch the create thread with object. And so we're going to run the same com server, the same method, but we're using a different callback. So we're going to basically create 31 callback objects and launch the create thread with object 31 times. And we did all of that like pretty quickly within the scan. And we'll come back to here. This is our callback object that we created basically on that second form. And I liked, for my callback objects, some personal preference, I like to use a PRG based class. Most of mine would just be a custom class. And I tried to look at it as sort of like a JavaScript promise type system, where if it was a successful call, I want to call onResolve. If there was an error, I want to call onReject. That's a personal preference. You can make it anything you wanted. I think 10 years ago, I called it like process result. And then 5 years ago, I had process result and process error. And now I just kind of like sticking with on resolve and on reject. So, and this on resolve function did basically the exact same thing that the other code did in the other form. We have a second class here called the author's handler, and it has a URL property, which we actually included as a parameter when we created the callback object. When we did the new object, we passed in the URL from the grid or from the cursor that we wanted to check. And when the DLL was successful, it would call back on resolve and basically send back the author or the title for that page. And the only thing our handler has to do is, if the cursor's open and we have a string, update the author where the URL is equal to our URL, our property for URL for this callback object. And then at the end, as soon as it's done with that, it calls this release. And we'll do the same thing if an error occurs. If an error occurs, we'll do something, and then we'll call this release. And then when you get to the release method, I add a release method to every one of these objects. And the only code in there is release this. And I'll show you why we do that in just a few minutes. Let's see, that was our get blogs, and this is our get author. When I first wrote this, like 10 years ago, get author, it accepts that callback reference, and then it just goes out and gets the web page. I used to just return the web page back and let the callback object handle the parsing to get the author name or the title out of it. But I decided to put that into the multi-threaded DLL because why put the extra processing in my application or in my main application thread, which is where the callback is running? Why not do all of that work here in the separate thread and then just let it send back that little piece that we need to update the cursor with? Rick, do we have any questions yet? Because I feel like I'm already getting into weeds here.
It's okay, because Christof is answering questions left and right behind the scenes.
Awesome. He's not telling everybody I don't know what I'm saying, does he? Is he?
No, he's not. But one question he hasn't answered yet, because it just hit the chat, is, does the multi-threaded call have access to cursors in the data session from the calling proc to read write values?
It does not, and we'll cross that bridge when we get to disadvantages.
Okay, and then another question, is there a way to control a thread while it's running? For example, cancel it, which I think was answered already by Christof.
Okay, yep.
All right, that's it.
All right. So we're on a roll here. This is like the best thing in the world. You know, when the first time I gave this session 10 years ago, Christof was sitting in the front row of the room where I was giving the session. On the one hand, I was scared to death doing the session in front of him. And on the other hand, it was super nice having him there because he could answer any questions I couldn't answer. So I'm so glad that we got him back this year. We'll take a look at creating those event handlers or callbacks. And, you know, the event handlers, they could be any Visual FoxPro object. Like I mentioned, my personal preference is just a PRG-based class, whether it's custom or whatever. You could conceivably even have a callback that was just a text box on a form. You saw earlier, I had callbacks that were a Visual FoxPro form, and I just had the method that the DLL would call for the callback. Using the PRG-based like custom controls, I can add properties and methods to that callback or event handler that extends their functionality. But not only does it extend their functionality, if you go back to the question about the cursors and data sessions and things like that, your DLL, your multi-threaded DLL, knows absolutely nothing about your application except what the callback knows and what the callback exposes to the DLL. So I have in the past, I've actually had the callback that would have a property for like app that would be assigned my global application object. And then all of a sudden, when you're into your multi-threaded DLL, the DLL can say, hey, callback, do you have a .oapp property? You do? Oh, cool. Now I know everything there is to know about your application. And I could do almost anything I wanted with that. So that's one of the reasons why I like using the PRG based and custom classes, is that I can add all these properties and basically expose them as I want to the multi-threaded DLL. It goes without saying that error checking and error handling is very important. You're not going to see a lot of that in this session because otherwise it would take me about 4 times longer to put a session together. So I just kind of hope for the best when I do my demos. And everybody, I think, has their own way of handling errors and doing error checking. But I will talk about some of that towards the end with the disadvantages. Let's talk about managing threads. You know, it's funny because you could actually launch as many threads as your processors and memory could handle. So in fact, I've got a demo where I'll show you, like, well, I'm just going to launch like 400 threads all at once and see what happens. But the trick is, how do you manage those threads? How do you know how many you've created? How do you know how many are done or completed? How do you know how many may still be hanging out there if the user tries to close the application? And as a real world example was the application where I first started using the multi-threading. We used like a queue system where you could tell it, hey, I want to do these 200 web requests to check, you know, exact search results on Google. And then I want to check 100 of them for like a broad search on Google. And it would queue them up, and basically in the background, the multi-threaded objects would just call Google periodically and say, hey, let's get a result for this one. Let's get a result for that one. But I would have callback. I would have a callback object for every single one of those threads that I was running. So if the user tried to close the program, I wanted to be able to tell the user, hey, by the way, you got 150 things in the background that have not yet completed. Do you really want to close, or do you want to just let the application keep running? And if they closed it, I would just save to a table what they had queued up and then start it back up again the next time they started the app. But one of the easiest ways to manage that is with a collection object. And back in the day, I would have a global application object that I would call like geo app, and I would add a collection to it. And I think I got really fancy with it, and it was called like thread manager because I'm very verbose and I like to use a lot of characters. But you could actually just create a collection object and then add it to the underscore screen or even underscore VFP, because they're going to be available to you anyway, right? No matter what you're doing in your application. And the easy way to know how many threads haven't finished yet is to check the count property, because what happens is every time you create a callback, you'll add your callback to that collection. And if you add a release method to your callback objects and release them when they're done, they automatically remove themselves from the collection, or they're automatically removed from the collection. So I don't have to worry about garbage collection. I don't have to worry about cleanup. I don't have to worry about doing remove and checking indexes and all that good stuff. They take care of themselves for me. And I can show an example of that. And this may be a pretty ugly example, but we'll try it anyway because it's all I've got. And I'm going to apologize now if you hear some scratching sounds, or if you hear dogs barking, or if you hear any roosters crowing. It's because my wife wanted 4 cats and 4 dogs and 8 hens and 2 roosters. But I'm the man of this house. So we got 4 cats, 4 dogs, 8 hens, and 2 roosters. And my microphone on my laptop really picks up pretty much everything in the house. So I have a dog scratching at the door, and I have 2 dogs outside barking right now. This little demo here, I want to show you a couple of objects. These are just plain old session objects. One of the classes is called Object with a Release, and it has a release method, and all it does is release this. The other class, session class, is called Object No Release, and it doesn't have a release method. And then, of course, I've just got a plain old collection that I call My Collection. This program, we're going to create the collection, and then we're going to go through and just create 10 objects. And every third one will be an object that does not have a release method. And then all the other ones will be an object that does have a release method. And then we're just going to run through and check the counts and all that good stuff. I'm going to close that and do, please release me. Okay, so as it was going through, as it was creating the objects, it said, okay, here's the first one, it has a release. Here's the second one, it has a release. Since it's a third one, there's no release. So every third one did not have a release method. Then we go to the end of the collection, and we're going to work our way up and just report back what the collection count is. Because for each object, we're going to call a release method. If there is a release method, release it. And so then as we go along through the count, you'll see that by the time we're done, we only have 3 objects left in that collection, because the 7 that had a release method automatically release themselves. Or not automatically release themselves, were automatically removed from the collection since they had a release method. The other 3 are still just dangling out there. And while we're here, we'll just take another look at this. Is just a regular form, and I'm going to launch like 400 threads all at one time. So you can keep an eye over here on the task manager. Right now, there's 2 threads inside of that VFP exe. When I click the go button, we're going to add 400 threads. And you can see that thread count's rising. And then basically I've got a timer control that just constantly checks as the threads are released and reports the number. And now I know that they're all done because there's 0 remaining threads. And that's kind of the beauty of using like a collection and having your callback objects contain a release method so that they can just automatically remove themselves. If I take a look at the class, you'll see why I called the DLL nothing.dll, because this DLL really doesn't do much of anything. It is just a session class. Of course, it's marked OLA public to make sure that it's a com server. It's got a function called do something, and that's the function that we're calling when I set up when I run the or create each individual thread. I'm telling the callback to say or I'm telling it to run do something. Sorry, I'm getting myself confused here. And then I've just basically put it to sleep. So this method really does nothing except sleep for 7.5 plus a random amount of time, 7.5 seconds plus a small random amount of time. And then it just returns a string back to the callbacks on resolve. But what I did with this particular object is I put a bunch of string to files in there so that we could actually go back and look and see what was happening while those 400 threads were running. And I put that in the kevdebug.txt. So I started running it at about 12:52 my time. And so this init, now remember, every line in this text file is coming from a DLL. So it's only the DLL that's writing to this file. But you can see I've already created 2, and then I've already called do something and passed in a callback. And so it's just going to kind of scroll through here. I mean, it's creating 400 of them. This could take us a little while. I could go line by line and make sure that we actually fill in 75 minutes, but I won't do that. We're just going to keep rolling right along here. But you can see that things happen, and it's really strange because, like, for instance, I'm losing my cursor again, but here, you know, we called do something on object number 63, and then 65, and then 64, and then 39, you know, and so they're happening out of order, but they're all happening pretty much at the same time. And the reason I put the destroy in there is basically because of a question that I got the first time I did one of these sessions, was what happens to the DLL when it's done? Is it still hanging out there? Is it still dangling? And it's not, because the Dmalt DLL takes care of this part for us. We're telling it which method we're running, and we're telling it what callback, what our callback object is. So when we run our method and then we make the call back to the callback, then there's no need for it to keep running. So it does end up getting destroyed. And you can see that in each one of those instances, it was, you know, destroy, 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 destroy. I did want to take a look and see when this ended. And I'm going to apologize again because I keep losing my cursor. 12:53 and 4 seconds. And we started at 12:52 and 15 seconds. So the whole process took 14 seconds. And that was initiating 400 separate threads. And of course, it had that wait time for each one of them. And then it processed, it called back to the callbacks, and they did their thing and all that. If I do a Control A and a copy, and then I go back to FoxPro, let's see if I have. We're just going to look for the word destroy in our clip text. Boom, 400. So I had 400 objects that actually ran the destroy method. And I just happened to have 400 threads that we started running right there. And I should probably ask any questions at this point.
Yeah, just one, or actually two. Will the samples that you're demonstrating be in the source in the downloads?
Yes, I haven't packaged them the way that I want to package them, but I will be zipping those up today and passing them on to the organizers to upload to the website. Okay. But yeah, basically all of these examples, they will be there. Yeah.
Okay. And if I'm running 30 copies of my exe on an RDP server, and I want to have parts of my program run in parallel, will it work in the above environment?
I don't see why not. You know, you're really only limited to whatever memory you have and the number of processors you have. Although I may not understand the question completely, so that may be one where it'd be worth sitting down and talking through.
Yeah, after in your post-session session.
Yeah.
Mm-hmm. That's it.
Okay. I think I had this was our handler for this one. And basically when I came in, I passed it whatever our count was. So we ended up with handler 1, handler 2, handler 3, all the way to handler 14. And I wanted to make sure that that was available to the DLL. I think I did something with the DLL there. I got the name, this name. Oh, there we go. Yeah, in the do something function, I did a string to file and said do something, the TO callback name. So in that instance, it would be like handler_1. So it was just a way of watching everything as it went along. So and then of course in the init for the handler, I did the thing where I checked to see, do we have an underscore screen .othreads? If we don't, then let's just add a property to the underscore screen called othreads, and it's a create object collection. Boom, it's just a plain old collection. You could create your own collections if you need some type of management system set up. You could always subclass collection and add that. Otherwise, I look and see, okay, there is a underscore screen O threads. Is it an object? If it's not an object, I want to remove that property and then just re-add it with create object collection. I could also do a check there to see, make sure that the base class is a collection. I just didn't do that in this case. So, but anyway, when the handler is created, when it initializes, it adds itself to that collection. If the collection doesn't exist, it creates the collection, then adds itself. And then, of course, I have that one function called onResolve. And of course, I have a release method to make sure that once it is released, it's let go of from the collection. And this is the real trick. It's like when I called in, I created the thread and said, I want to run do something. And I passed in the callback. Sorry, I'm still looking for my cursor here. Here we go. When I'm done with my method in the DLL, I want to call a function in the callback just to say, hey, here's the result. You know, it was good, it wasn't good, you know, blah, blah, blah. In this case, I'm just sending back a random string. And I called the function onResolve, and you'll see that the handler also had, or you did see, the handler also had a function called onResolve. That's the one that gets called from the server. This is what it looked like when I created the threads. And basically, I just said, oh, okay, it was 400. So I declared the DLL, made the Windows API for close handle, and then I just walked through that number. And for each one of those handlers that I created, I passed in whatever the count was, and then it would change the name of that handler to handler_1, handler_2. Our DLL was called nothing. The class was called nothing. The function that we wanted to run or method was do something. And the callback object, the reference, the COM reference was underscore VFP eval, the callback object, LO callback. And that was it. It creates those 400 and they go off and they do their own thing. And then as things get finished, the DLL goes away, and then the callback, when it's done, it releases, and the collection gets itself cleaned up as a result of that release. And now we'll hop back over to the presentation, to the slides. What else can I do? That's one of the coolest things. Is like, wow, this is really super cool. I could think of a million different ways I could use this, but I wonder if there's anything else I can do. And in Christof's article, he mentioned several things you can do. You can allocate memory. You can pass the address to both threads and use sys 2600 to exchange data. There's inter-thread communication. And I believe on Christof DLL for a session that he did many, many years ago, that actually shows some of the inter-thread communication. Also, he has some examples for the create thread with string if you're interested in that. He also mentioned in his documentation about events, critical sections, and a lot of other big words that I didn't really understand, which also includes all the other words on this slide. So you can do a lot of things, but I'm not the person that you really want to ask on how to do those things. But now we have to ask, okay, it's great. We've got advantages of using multi-threading, but are there any disadvantages? And the answer to that is yes. Every single thread is a new instance of the VFP runtime, which means the variables and global objects and work areas are different for every single one of those instances. Not only that, those instances have no idea about your application's variables, global objects, work areas. You can't really say, here's my cursor, go do something with my cursor to the multi-threaded DLL. But what you can do is if you want to do, if you need to crunch some numbers or crunch some data and stuff, you could use a cursor to XML for your callback. Pass that XML to the multi-threaded DLL. Then of course it would do an XML to cursor, and it could manipulate the data, do what it needs to do, and then do a cursor to XML and send it back to the callback, or send the results back to the callback that you need. I also put in here that you could use Json serialization for that. 10 years ago, it didn't seem that JSON was a thing, but cursor to XML was. These days, a lot of stuff I do has to do with JSON, and I would be just as inclined to serialize the data that way and just pass it to the multi-threaded DLL. When I say pass it, it's really just kind of like a property on your callback object, and then the DLL could just read it. You could conceivably send it in. I mean, you could run the function and send it in as a parameter too. So, but that's one way that you could use to pass data back and forth. And that was something I was going to say earlier when I was talking about the 5-second rule. Say you may want to create like huge Excel spreadsheets or something, and there's several VFPX projects that take care of that. But if it's a whole lot of data and a whole lot of crunching going on that needs to be done, why not pass it off to a separate thread? Have it do all that work while your user can still use your application. And then when the multi-threaded DLL is done, it could just call back to your callback and say, hey, by the way, I'm done. And here's where the XML or where the Excel file is. So then your callback would raise that to your application and say, by the way, here's your Excel file. Would you like to open it? You know, or whatever you want to do with it. The same thing with what was the other cruncher? I thought of something earlier and I can't remember what it is now, so I'm just going to jump ahead. There are more disadvantages. We call this disadvantages part 2. Every multi-threaded DLL is a different project in FoxPro. So it can get pretty hairy if you've got like one big monolithic application and you've created 4 or 5 multi-threaded DLLs that may all do different things. All of a sudden you've got your one big project for your monolithic application, and you've got 4 or 5 other projects, for one for each DLL. So that can get a little hairy for you. They are extremely hard to debug. In fact, all the string to file stuff that you saw in that last demo that I did, where it was just, I just wanted to see how everything was working and running. I'll spend a ton of time with string to file when I'm actually developing them. Trying to debug a multi-threaded DLL by just instantiating that class in the FoxPro IDE, there's no way you're going to get the same results, because you're all running within the same process and within the same thread, so that it knows what your environment is, and it knows that this table may be open or this cursor. So it's extremely hard debugging it. That means that there's a lot more planning involved, and planning equals time, and time equals money. So the question is, how do you work that out? So and it does use a different runtime. So a multi-threaded DLL uses that lightweight FoxPro runtime, the VFP9T runtime, instead of the VFP9R. The biggest difference is that the VFP9T is a lightweight runtime, and the main reason for that is there's no user interface stuff inside of there, because you can't have user interface in a multi-threaded DLL anyway. So why have it in your runtime? And any further questions, Rick?
Any recommendations concerning reentrance of a callback function?
I have no idea. So that's a terrible answer.
Well, that's the only question we had remaining.
Yeah, that may be one for Christof. So, well, we are at the end, and still had about 5 minutes to go, but just looking back as a summary at what we learned today is that multi-threaded Visual FoxPro apps are possible, and using Christof's DLL makes it relatively easy to do. Once you get your head around what it's doing, it makes it pretty easy. So I'll take this opportunity to say thank you, and please fill out your evaluations. And I guess I'll be available for the question and answer session in a few minutes. And then if anybody wants to hit me up at any time, you can always feel free to email me. So.